What is up, pre-algebra students? This is lesson 15, and our objective is understand roots and exponents. By the end of this lesson, you should be able to understand roots and exponents. Before we get started on roots and exponents, let's remember something. Back in elementary school somewhere, we learned 2 plus 2 plus 2 plus 2 plus 2. There's an easier way to do that. You could just say 2 times 5. 2 times 5, because there is 1, 2, 3, 4, 5 2, so we could just say 2 times 5. Likewise, we could say 3 plus 3 plus 3 plus 3 is the same thing as 3 times 4. So this number over here was how many there were. Over here there was 5 of them, so that means you put a 5 right there. Over here there was 3 of them, there was 4 of them, so that means you'd put a 4 right there. Likewise, now we can do something similar with multiplication. If we have 2 times 2 times 2 times 2 times 2, notice we have 1, 2, 3, 4, 5 of them, so I can say 2 to the 5th, or 2 to the power of 5. The 5 is because there's 1, 2, 3, 4, 5 of them. Same thing with here, 3 times 3 times 3 times 3, I can say 3 to the power of 4, or 3 to the 4th power, because there's 1, 2, 3, 4 of those. Okay? Just some terminology, this number here, like the 2 or the 3 over here, so we call the base, and this number up top, the little one, and the superscript, so we call the exponent. And simply, x to the a means x times itself a times. So it means whatever number that is, you're going to multiply it by itself this many times. Alright, so simplify or simply means expand and solve, or find the value. So let's see if we can figure this out. 4 to the 3rd power, that means 4 times 4 times 4. Notice there's 1, 2, 3 of them because my exponent is 3. Well, 4 times 4 is 16, so I'm thinking 16 times 4. 4 times 6 is 24. 4, 5, 6. So my answer is going to be 64. Over here for part B, 10 to the 5th power, that means 10 times 10 times 10 times 10 times 10. Again, 1, 2, 3, 4, 5, because my exponent is 5. So this is going to be 1 with 1, 2, 3, 4, 5 zeros after it. A 1 with 5 zeros after it. That's your answer there. Alright, next one is, this is like example 2. It says, write the prime factorization of this using exponents. Now we already know how to find factorizations. If you don't, go back and watch that video. Pretty much you just try to find two numbers, multiply to get that one, and you keep going, you find a factor tree. So I went ahead and did this, so just to save some time, notice I've got that all the way down where all these numbers at the end are prime numbers. So I'm just going to write them in order here. 2 times 2 times 2 times 3 times 3 times 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Alright, excellent. So notice I have 3 2's that are all multiplying. So I could write that as 2 cubed. And notice I have 2 3's that are multiplying. So it'd be times 3 squared, or 3 to the 2nd power. And I just have 1 5, so I'm going to say times 5. I could put a 1 there if I wanted to, but generally if the exponent is 1, we just don't write it, so we'll leave it like that. Alright, express this with exponents. So let's look here. This says 11 times a times a times a times a times a times b times b times c. So I'm going to look right here at my a's. Notice I have 1, 2, 3, 4, 5 of them. So it's going to be 11 times a to the 5th. The b's, I have 3 of those, so it's going to be b cubed, and then a c. So that right there would be my answer. I'm just writing it with exponents, shortening up that thing a little bit. Alright, so that gets us through exponents, so now let's look at roots. And roots are the opposite of a power, or opposite of an exponent. So not like roots of a tree, but the opposites. Kind of like addition, subtraction are opposites, multiplication, division are opposites. Exponents and roots are opposites. So just some terminology, this number inside, well I guess this symbol, so we call the radical symbol. It's like a hippie, it's all radical and stuff. The number inside here is what we call the radicand. Make sure you don't call it a radicant because it canned. And this number out here we call the index. Now, if there is no number right here, then we call that a number 2. It's implied that it's a number 2. So if you see no number there, then we know it's a number 2. So pretty much what this means, it says what number times itself a times will give you x. So what number times itself this many times will give you this one. So again, let's look at this. Notice this first one we say is the square root of x because there's no number right there. It's implied that there's a little 2 right there. But since there's no number written, we just know it's a 2. So I'm thinking of what number times itself will give you 25. That 5 times 5 will give you 25. So that means the square root of 25 is equal to 5. Alright, this next one is a cube root. So what we're saying is what times itself again will give you 125. Well, thinking a little bit, I'm figuring out, oh, 5 times 5 times 5 will give you 125. So that means the square root of 125, and by square root I meant cube root, is going to equal to 5. Let's practice a few more of these. The first one says the square root of 121. So kind of in a thought bubble here. This means what times itself will give you 121. Well, 11 times 11 will give you 121. So that means this is equal to 11. Remember, this is an implied 2. Right there is the index. Thought bubble again. Since this is a cube root, we're saying what times itself 3 times will give you 8. Well, 2 times 2 is 4, and times 2 one more time would give you 8. So that means this is going to give you 2. The answer is 2. Okay, now this next one says the square root of 5 squared. Well, if you remember what 5 squared is, this means the square root of 25. What we just did on the previous page is going to be 5. Well, if you notice something, right here is a 5, and right here is a 5. Seems like they almost undid it, and that's actually exactly what it did, because remember we just talked about enemies. The exponent and the square root do opposite operations, like addition and subtraction do opposite operations. So this would just have come out to be simply 5. Alright, your homework for today is on page 101. We're into the 3 digits now. All 15, all 14, plus 8 of your choice. Good luck.